Let's look at the next concept in motion in one dimension. And the concept is equations of motion in case of constant acceleration. The first equation of motion is V equal to U plus AT. These terms have their usual meaning, that is V is final velocity, U is initial velocity, and A is acceleration. And this is the terminology that we are going to use throughout the chapter. In fact, throughout mechanics. Right? And T, as we all know, it is time. Now, from where do we get this equation? This equation we get from definition of acceleration. We know acceleration is change in velocity by time. So A equal to V minus U by T. I cross multiply, I get AT equal to V minus U, or V equal to U plus AT. So I can say that this equation is outcome of definition of acceleration. Now let's look at the next equation of motion is S equal to ut plus half at square. Here u is initial velocity, t is time, that we already seen. Now what is S? S is displacement. We have to be very careful about this because many people have a confusion whether it is displacement or distance. And we know displacement is a vector quantity. So if it is a vector quantity, its direction has to be considered. Now let's see some simpler ways of applying this equation. Now, if a body starts from rest, initial velocity would be equal to 0. In that case, I can write S equal to half at square. So if S equal to half at square, acceleration is constant. So S is proportional to square of the time. So that means if body starts from rest, then I can say displacement of the body is proportional to square of the time. Let's take an example to see how this part simplifies our calculations. Let's say I take a question where the question says a body covers 100 meters in first 2 seconds. So this is the first condition, and the question is find the displacement in next 2 seconds. So how do we do it? In order to solve this question, I'll divide this part into 2 parts. Let's say this is S1 and this is S2. This is distance covered in first 2 seconds and this is in the second 2 seconds. Now initial velocity, we know it is 0. So because S is proportional to t square, I know S1 would be proportional to 2 square and S1 plus S2 would be proportional to 4 square. Now I can use S1 by S1 plus S2 equal to 2 by 4 whole square. So that will give me S1 by S1 plus S2 equal to 1 by 4, or I'll have 4 S1 equal to S1 plus S2, or S2 equal to 3 S1. What is S1? 100 meters. So the answer is 300 meters. So this saves time because we don't have to find acceleration and directly use the proportionality. Next equation of motion is V square minus U square equal to 2AS. So again, we know all the variables. Be careful, S is displacement, S is not distance. Even in this case, I can use that ratio and proportionality method. So that method will again simplify the calculation here. So I'll assume if there are 2 conditions, if U equal to 0, I'll have, that is initial velocity is 0, then V is proportional to root, V is proportional to AS, or I can say V is proportional to root S, right? And if V equal to 0, that is final velocity is 0, then U would be proportional to root S. So if initial velocity is 0, then the final velocity is proportional to square root of the displacement, or if final velocity is 0, then initial velocity is proportional to square root of displacement. So let's look at an example. Let's say I take an example that a vehicle is moving with at a speed of 20 meter per second. Right? A vehicle is moving at a speed of 20 meter per second, if brakes are applied. If brakes are applied, it stops after covering 40 meters. Right? If brakes are applied, what is happening? It is stopping after covering 40 meters. Now, if the initial velocity of the vehicle instead of 20 is 40 meter per second, and if the same brakes are applied, how much distance would the vehicle cover before coming to rest? So because in this case final velocity is 0, this question what we have? We have final velocity is equal to 0. So I can say u is proportional to s, or I can directly write u2 by u1 is equal to root of s2 by s1, where s2 is the distance the body covers before stopping in the second case, and s1 is the distance the body covers before stopping in first case. From this, what I can write? I can write, because I want s2, what will I do? I'll square on both sides. I can write s2 equal to s1 into u2 by u1 whole square. Or s2 would be equal to how much? S1 is given to be 40 meters, u2 is 40, u1 is 20 squared. So this becomes s2 equal to 40 into 4, that is 160 meters. So not only here, wherever we have a possibility of using ratios and proportion, the calculation will be very much simplified. So this is about equations of motion when the acceleration is constant. Again, as we told, all these three equations are valid only when the acceleration is constant. If acceleration is not constant, we cannot use these equations. So hope you could follow everything, and thank you very much for watching the video.